Hello friends, welcome to the class on gear trains. So here in this class we are going to see how to find out the velocity ratio of simple gear train. In the previous video we discussed about what is the meaning of simple gear train and compound gear train. So now let us see how to find out the velocity ratio of this, and it is very important for us to solve the problems. And see, this is the arrangement. So what is the meaning of simple gear train? So one gear is moved on a one shaft. So how many gears are here? There are four gears are there and four shafts is there. So here gear A machine with gear B, right? Then gear B is machine with gear C, and gear C is machine with gear B. Okay, so we need to find out the velocity ratio of this arrangement. So we know what is the velocity ratio, that is n2 by n1 is equal to t1 by t2, right? So we know the velocity ratio, general formula n2 by n1 is equal to t1 by t2. So this is the generic formula. So now, so here gear A is machine with gear B, right? So gear A measures with gear B. So then what is the velocity ratio? It will be, so n2 by n1, that is nb by na, right, is equal to ta by db. So let us assume this as the equation number 1. Okay, so now the gear B is meshing with gear C, right? Gear B meshes with gear C. Then what is the velocity ratio? So it will, see, this will become a driving and this will become a driven gear. Driving gear and driven gear. So NC by NB is equal to TB by TC. Right? So let us consider this as equation number 2. Now gear C is meshing with gear B, right? Gear C meshes with gear B. So then what is the velocity ratio? It will be ND by NC, that is equal to TC by TD. So this is equation number 3. So now what is the overall velocity ratio? So we are going to multiply equation number 1, 2 and 3. So what is 1? So it is NB by NA into NC by NB into what next? So NB by NC, right? So that is equal to TA by TB into TB by TC, TB by TC into TC by TB, right? So this is the overall velocity ratio. So what happens here? So NB cancels, NC cancels, TB cancels, TC cancels. So what is the meaning of this? So the overall velocity ratio of this simple gear train arrangement is ND by NA, ND by NA is equal to what? TA by TB. So this is the overall velocity ratio of simple gear train. So what is the meaning of this? See, here the power is being transmitting from gear A to gear D or vice versa. So here gear B and gear C acts as a intermediate gears. Okay. So here intermediate gears has no effect on the velocity ratio. Why? Because there are no terms related to N, that is B and C. So that's why it indicates the velocity ratio has no effect, or intermediate intermediate gear has no effect on the velocity ratio in the case of what? Simple gear train. So then what is the benefit of it? It is just going to fill the gap between gear A and gear B. And not only that one, it helps us in the direction of rotation. For example, if gear A rotates in clockwise direction, then gear B is going to rotate in what? Anti-clockwise direction. If gear B rotates in anti-clockwise, then gear C is going to rotate in clockwise. And gear B is going to rotate in anti-clockwise, right? So that means, see here, driver gear is rotating in clockwise direction. Finally, the gear D, the driven gear, is rotating in an anti-clockwise direction. What is the indication of this? How many intermediate gears are there? There are two numbers are there. That is, it is the even numbers. When even number of intermediate gears are there, driving gear and driven gear is going to rotate in a opposite direction. When odd number of intermediate gears are there, then the driving gear and the driven gear is going to rotate in a same direction. So this is the use of intermediate gears. It helps us in achieving the required direction of rotation, and also it is going to help in filling the gap between the driving and driven gear. So this is how we are going to find out the velocity ratio of simple gear train. In the next class, we are going to see the velocity ratio of compound gear trains.